moving on. I'll make, towards this, we're reaching the end of the talk. There'll be time for questions. I gathered 6 links to other open source or otherwise, there's a plus sign. Otherwise, not to respect Richard Stallman's distinction between free as in beer and free as in, what does it say? Free as in beer or free as in what? Speech. Okay, free as in beer, speech. Yeah. First, the Linux documentation project. Let me tell you a story about this. I brazenly borrowed I made reference to a few subsections of. Gosh, I forgot the author. If I met him, maybe I wouldn't forget. But this document that's published on the Linux Documentation Project website, the Linux Kernel Module Programming Guide. Everything that you needed to know to write Linux kernel modules about 5 years ago. And I purposely lead them to follow the directions here, and when they try to compile the module, the compiler burps. It refuses to compile. There's a compile error. When they follow the directions, it doesn't work. The lesson is, technology changes. You have to learn to deal with it. There was a change in the interface somewhere a few years ago. And so it teaches them, hey, read in the book. Books are printed. They don't change. But reality does change. So it's a lesson in life. Another source which I refer students to read, and sometimes I pull the websites up and show it to them, is IBM Developer Works. They have some excellent expository and technical material on various levels of GNU Linux, including the kernel. And then a cool, this is a horse of a different color. Margot Seltzer, who is a student at Berkeley, two of the people who developed the Berkeley Fast File System, which is the modern Unix type of file system, teaches a great course in Harvard. And she uses the same textbook that we do, the Tannenbaum book. The difference is that her course is based on the laboratory component of her course. It uses a simulator for a machine of some, probably her design, together with a tool suite. And so the students get, unlike what we do, we're not as ambitious as they are at Harvard, they get a fragmentary introduction to they get a fragmentary framework for the operating system, and they add the code to make it work fully. We're not ready to teach our students to do that. But her material, the system and software supporting it, is all published on the internet, available free. So we could develop new courses based on that. We could direct our more ambitious students to learn it on their own, send them to Harvard. Now, there's some of the Linux journal articles are available free. Here's a link to one of those articles about sleeping in the kernel. We teach that, the interface within the kernel for wake up and waiting. It covers issues about lost wake-ups. The tricky thing is a bread and butter of an operating system, people dealing with lost wake-ups and making sure it doesn't happen. And here's a cool one. I didn't make much reference to this in the course yet. A company called Free Electrons. They do embedded Linux and device driver development. embedded Linux, and they publish a lot of manuals under the Creative Commons attribution share alike license. So that's a step in the right direction. Or shall we say a huge leap in the right direction. And then here's a cool thing for the software carpentry. Again, I haven't found, or I haven't looked at this enough to determine whether it would be really helpful at the level we're teaching OS. It might be too simple. But this is an organization, all their material is free and open and reproducible and all that. That's designed to teach scientists, people who do science as a profession, to be better programmers so they can do better science. Software carpentry. And let's see, got anything else? Yeah, so the other thing I I have links to is specific things we do, like the Linux cross-reference site in Norway, whose infrastructure we could reproduce freely. I had no need to ask our sysadmin to work on that. But you could make a link. See, the link says L1237. This is a link to a particular line in the kernel sources of a particular version of a particular kernel release, which happens to be Linux 3.3. This is the definition of the task structure, which is the heart, the major, if it's the most important data structure in an operating system. It is the process table entry. The process table entry is the generic name for what in Linux the brand name is the task struct. So we show them that, we can link to it. Comes from Norway. Unfortunately, you do backing, it just backs up too much. We have them, sometimes we get the source trees by copying it from the vendor supplied source tree. Of course, there's a Linux kernel archive where they can download a tar file or a BZ file, BZip tar file of the pristine sources, some version. Yeah, build kernels, you know all about that. And, okay, here's the results. So one of the cool things we do is have them in a team. This is a team activity. They crawl through some code and they draw diagrams. Like here we go. Starting at the process table entry, the task struct, there's a pointer to the memory management structure. And then there's an active memory management structure, which is, why they use it is a mystery. So ask questions is a good thing that they learn to do. So the active memory structure is this thing, and it has a pointer to the VM area struct. The VM area structs are actually in a linked list. They diagram out the scalar fields within the memory management structure. They learn very concretely that every task has a number of data structures to keep track of its stuff. One of them is the memory, the other is the other stuff. So we have a few links like that, and I think that's about it. Almost. Yeah, I don't think I had anything else. There's some particular things outside the kernel from the GNU people, our friends, Richard Stallman and all of his friends. I have to give lip service to them. I really do, because we're concentrating on the Linux kernel, which is not GNU, but we do use GNU utilities to disassemble stuff. In the course, we disassemble Intel machine language to show line by line what the machine does and what happens when there's an exception or a system call. And then we have them use DDD, which is an interface to GDB, all now currently on the GNU project, to really learn what they didn't learn coming into the class, what they didn't learn before about how C actually works. Memory model of C, which is the hard thing to teach. Thank you.
Yeah, thank you.